Hello class, in this video I'll be showing you how to graph a linear inequality and how to graph a system of linear inequalities. Let's begin. So we want to graph the feasible region for the system of inequalities, and then we want to tell whether the region is bounded or unbounded. So what I'm going to do is I'm going to start by labeling my equations. So I'm going to label the top equation L1 for line 1, and the bottom equation I'm going to label L2 for line 2. Starting with the top equation, I'm going to solve it for y. So L1, I'm going to solve this equation for y. And I'm going to keep y on the left-hand side of the inequality, and to do that I'm going to subtract x from both sides. So the slope is -1, and the y-intercept is 0, 1. Okay, now we're ready to graph the boundary line. So since y is less than or equal to an expression, this implies that the boundary line is solid. Okay, so starting at 0, 1, the slope says to go down 1 to the right 1, down 1 to the right. We can also go up 1 to the left 1, and here is the boundary line. Next is where to shade. So we have less than or equal to, which means we're going to shade below. So the solution is below the line. The feasible region is below the line. So I'm just going to place little arrows right here to represent below the line. Okay, next is L2, the second line. I'm going to solve that equation for y. So again, I'm going to subtract x from both sides. And then I'm going to divide all three terms by -1, which means I have to reverse the inequality. It doesn't flip. Doesn't change directions, it reverses. So in this case, the slope, which we'll label m this time, is 1, and the y-intercept is 0, -2. And now we want to graph the boundary line. So since we have y is less than or equal to, that implies that we have a solid boundary line. So starting at 0, -2, the slope says to go up 1 to the right 1. We can also go down 1 to the left 1. And I want to graph that line now. And notice that my line extends from one end of the grid to the other. Now, where do we shade the feasible region? So in this case, it's the same as the other line. Since y is less than or equal to some expression, the feasible region is below the line. So I'm going to place two arrows to indicate below the line. So the feasible region for both linear inequalities is going to be where the two feasible regions intersect. So in that case, that's going to be this area right here. And in this case, the feasible region is unbounded. Now I can check my work by picking any point in this feasible region and seeing if it provides two true inequality statements. So what I'm going to do is I'm going to pick this point right here, 0, -4. That is in the feasible region. Let's see if it makes both of these inequalities true. So here's a check. Then I'm going to check the coordinate 0, -4. So for line 1, that would be 0 plus a -4 has to be less than or equal to 1. So is -4 less than or equal to 1? That is very true. And for the second line, 0 minus -4 has to be greater than or equal to 2. So 4 is greater than or equal to 2, and that is also true. So we have shaded in the correct location, and that is the feasible region and the solution to this system of linear inequalities.